All right, let's look at the homework 3.4, problem number 7. All right, so we want to find the point on the graph of f of x is equal to square root of x plus 6, which is the closest to the given point 19, comma 0. All right, so let's do that. All right, so any point on the graph can be written as, so we don't know the x value, but so I'm going to call the x coordinate x. And the y coordinate is going to be f of x, right? So I can put the square root of x minus 6, right? Then we want to basically minimize the distance between this point and the given point 19, comma 0. So what we can do is we can think of this as maybe I should think of this as x1 and y1, and this is going to be x2 and y2, right? So if you go through the distance formula, you're going to get, so we want to minimize, right? So we want to minimize the distance. So I call it d or something, right? And this is equal to, right, square root of, right, so it's going to be x2 minus x1, which is 19, right, squared, plus y2 is a square root of x minus 6 minus y1, 0, right, squared, right? So this is the quantity we want to minimize, right? But since I don't like square root, if we can avoid it, I'll try to avoid it. So if you want to minimize this distance, if you can minimize the quantity inside the square root, that same x will minimize the distance too. And if you want the distance, you can just take the square root later. All right, so I'm going to simplify this problem into, we want to minimize just the expression inside the square root, right? So we get quantity x minus 19 squared plus, right? 0 doesn't do anything, so I'm going to just so I'm going to scratch 0 out. Let's see, I want to use a different color here. And since square root gets squared, so square root is gone, right? So we simply get just x minus 6, right? X minus 6, right? So if we can find the x value that minimizes this function, the same x value will minimize the distance, right? So let's find the critical number. Actually, let's see. So the range, the x can move from, right? So since the domain is the 6 to positive infinity, so you have domain the 6 to infinity. All right. So let's find a critical number. So I'm going to take the derivative. So derivative is f prime of x is equal to, right? So general power rule, put 2 in front and keep the same inside function, right? And then subtract 1 from the power. So 2 minus 1 is 1, so I'm not going to write that. Then multiply by derivative of inside, which happens to be 1, so times 1. So I'm not going to write that because it gets messy. All right, so that's the derivative there. And derivative of x is obviously 1. And the derivative of negative 6 is 0, since negative 6 is a constant. All right, so we have that. So we can clean this up a little bit. So this is going to be, all right, so I'm going to distribute 2 to x. We're going to get the 2x, right? And then I'm going to distribute 2 to negative 19. So we're going to get negative 38. All right, but there's a, I'm going to go ahead and combine it. So negative 38 plus 1 is going to be negative 37. All right, So we set that equal to 0. Right? So by solving that, we can find a critical number. So first, I'm going to move 37 over to the other side, becomes positive 37. So you add 37 to both sides. Then you have a 2x is equal to 37. Right? Then we have to get rid of 2 in front of x, so we can just divide through by 2 to get x is equal to 37 over 2. Right? So this is a critical number. Right? We have that. Right. So since let's see, so this derivative is just the linear function, so it's defined everywhere. So there's no critical number of the second kind. So we only get one critical number of first kind. Right. Then we want to make sure that this will actually give you the minimum instead of maximum or neither. I'm going to do a little bit of increasing, decreasing analysis here. Right, so draw a number line. Right, then since the domain starts from 6, so I'll put 6 here. Right, then I put up tick marks for 37 over 2. 37 over 2. Right. Then we're going to look at the sign of f prime so that we can discuss the increasing, decreasing behavior of original function f. All right, so sample number between 6 and 37 over 2, x equals maybe 10 or something like that. So x equals 10, right, is bigger than 6, that's smaller than 37 over 2. And anything bigger than 37 over 2, so x is equal to, say, 20 or something like that, right? Then we're going to look at the sign, right? So derivative we're looking at is, let's see, which is the simplest. So this is the simplest derivative right here, right? So if you plug in 10, you have 20 minus 37, which is a negative number here, right? And if you plug in x equals 20, so 20 times 2 times 20 is 40, minus 37 is actually positive, right? Which indicates that the original function f, which we're trying to minimize, is decreasing before the critical number and increasing after the critical number, right? So now we know that for sure that the minimum occurs here. You can see that we're looking at the bottom of the valley. So it's going to be, this is going to be the minimum, right? So this x value minimizes the f of x, which same x value will minimize the distance. It's just a square root of the same function, right? All right, so all you have to do to answer the question would be we just have to find the corresponding y value, right? So corresponding y value is you take the original function and plug in x value we just found, 37 over 2. So this is going to be equal to square root of, right, x is 37 over 2, right, just to plug it into the original function. And then we have to subtract 6. 6 is same thing as 12 over 2, so I just take the common denominator. Right, so we have square root of, right, 37 minus 12 will be 25, so 25 over 2. Right, so therefore the closest point is x coordinate is 37 over 2. And the y coordinate is square root of 25 over 2. All right, let's type it in. All right, so what we found was, let's see, 37 over 2. So 37 over 2, comma, right? Then you have a square root of 25 over 2. All right, let's check the answer. All right, it came back and looks like we got the closest point correctly. All right, That's it. I hope that this was clear.